Hi everyone, let's continue. So last time we proved the trig limit sin u over u when u goes to 0. This limit equals 1. Okay, so today we're going to talk about the derivatives of the trig functions. Do you remember this table? Okay, I hope that you can memorize this formula. Okay, remember sine, cosine, they're a couple. The tangent, and there's two secants x, they are family members. So the derivative of sine is cosine, derivative of tangent is secant squared, derivative of secant is secant tangent. And the second row, the derivative of the cofunction is negative whatever derivative on top of it, right? So derivative of cosine is minus cosine is like minus sine. Derivative of cotangent is minus cosecant squared. Derivative of cosecant is minus cosecant cotangent. Okay, so right now, we're going to use these formulas to find the derivatives of combinations of the functions with combinations of these functions, okay, trig functions and the power functions. Also, I want to remind you the power rule, x to the n derivative is n times x to the n minus 1. And the derivative of e to the kx is k times e to the kx. Remember, father looks like the sun, but father has the mustache. But don't put e to the kx minus 1. Don't change the exponents. The father looks exactly like the sun, but just the father has the mustache. So k is like the mustache. Okay. All right. So we're ready. First problem. Okay, so remember when we take the derivative, we look at the formats of this function. The format of this guy is like quotient, so we use quotient rule. So make sure each step we only do one thing. Okay, so quotient rule, then we just write out the quotient rule. Quotient rule at the bottom is the original denominator square. And then the numerator is the top guy prime times second guy, and then minus the top guy times the bottom guy prime. So far so good, everybody? Okay, so let's continue. So the bottom we have this. And let's continue. Let's find the derivative of secant x. Well, secant x derivative is secant x tangent x. Okay? Derivative of 3x is 3. Don't forget the parentheses, okay? And we just copy this down. So we copy this down. The derivative of e to the 2x is 2e to the 2x. The derivative of tangent is what? Secant square. See? Now we have take the derivative of all the terms. There's no prime left. Then we're done. Don't need to simplify it. It's okay to leave your answer like this, as long as all the factor you don't see the prime anymore. Okay? Let's continue. Okay, so part B, let's look at the format. Well, this is a difference, so we can differentiate the first term and then minus, we can differentiate the second term. But the first term you can see is a product. So we actually need the product rule for the first term. So we can think about is this guy times this guy. So the product rule is the first guy prime times second guy plus the first guy times second guy prime, right? This is the first term. And then we also need to take the derivative of the second term. So constant multiple, leave it there. Derivative of cosine is minus sine x. So I hope that you're familiar with the formula, okay? So every day, every class, we're learning something new. So after the class, when you get home, make sure you can memorize the formula we go over that day, okay? So because with every class we're learning something new. If you don't review what you learned and you don't memorize the formula, your pile is just getting more and more and more. Okay, so yeah. Yes, so catch up, follow our speed, and memorize the formula after class, okay? So 13x cubed, what's the derivative? Well, that's 13. We multiply by 3, so that's 39x. 3 minus 1 is 2. Okay. And then we have 13x cubed. Derivative of sine is cosine x, right? And then minus become plus 5 sine x. So far, so good, everybody? Yes. Let's continue. Okay. So let's see. Oops. Okay. All right. Let me see. Okay, so let's continue with this problem. So what is this guy? Is a quotient, right? So we use quotient rule. Well, oh, sorry. I think I changed something wrong with it. Okay, so I should not change it. Okay, so just leave it like that. Okay, so here we're gonna use quotient rule, right? What's quotient rule? So we have the bottom is the bottom guy square. The top, then we have the top guy prime. Don't forget the parentheses. Times the bottom guy minus the top guy times the bottom guy prime. So even though the problem was so complicated, but don't worry, write out step by step. So each step we only do one thing, so we won't get confused, okay? So here we use the quotient rule. So we write out the quotient rule. The next steps is whenever you see the prime on top of the factor, you're gonna differentiate it. So derivative oops. Did I do something wrong? Oops. Why this change? Okay, I don't know why. So what is this guy? Okay, so oh, I think, is it because okay, anyway, I have no idea. It suddenly just changed. Even though I go back, it wouldn't work. Oh, is this 9 secant? Oh. Okay, let me see what's wrong. Okay, and is this 5? Okay, is this the one we have? I think so. Okay, I try to not touch it. Okay, so we continue, right? And so the first thing we have derivative of sine is cosine x. And then minus 9, constant multiple stay there. Derivative secant is secant tangent. Remember, one tangent and then 2 secants, they're family members. So the family member of secant is secant and tangent. Okay. And then 5 plus x tangent x minus 4 sine x minus 9 secant x. Derivative of 5 is 0. Oh, but the derivative of x times tangent x, you see, this is a product. So we use product rule. First guy prime times second guy plus first guy times second guy prime. And then the denominators stay the same. Alright, let's continue. So we have 4 cosine x minus 9 secant x tangent x. And 5 plus x tangent x minus 4 sine x minus 9 secant x. Okay, what is the derivative of x? That's just 1, right? So we have 1 times tangent is tangent. Well, x times derivative of tangent is what? Secant square. Alright, and then we just copy this guy down. And we are done. See, each step we only do one thing. The first step we do the quotient rule, and the second step we calculate this guy and this guy, right? We take the derivative of them. And here we use the rules, and then here we use the product rule. So we write out the product rule, and then the last step we figure out, oh, what is x prime or what is tangent x prime, okay? So each step we only do one thing, so let's do it step by step. Alright, let's continue. Well, this guy, the format is products, right? So for products, we can use product rule. That is the first guy prime times second guy plus the first guy times second guy prime. Well, e to the 2x derivative is 2e to the 2x. Cosine x stay here. E to the 2x stay here. Derivative of cosine is minus sine x. And that's it for this problem. Yes. So write out the steps so you can get partial credit even though you might make a mistake somewhere. Okay. Next, we want to find the 20/20th derivative of sine x. Okay, wow, that's a lot. We actually need to take 2020 derivative of that. Let's see. Okay, what's f prime? Derivative of sine is cosine x. What's f prime prime? Derivative of cosine is minus sine x. Derivative the third derivative of minus sine is minus cosine. The fourth derivative of cosine is minus sine, but minus minus become positive. Ooh, do you see this is the same as this guy? So when you take the fifth derivative, oh, it's just gonna be repeat. And then when you take the sixth derivative, it's gonna repeat and repeat. So it repeats every 4 derivatives. Okay, so I can summarize the rule. So this is the first derivative and the fifth derivative. So this is like 4k plus 1 derivative, where k is any integer. Well, this is like 4k plus 2. Yeah. How about this one? 4k plus 3. And how about this guy? Do you want to say 4k plus 2? 4k plus 4? We don't need to do that. Just 4k is enough. Okay, so right now, we just need to see what is 20/20? Well, 20/20, we want to divide it by 4. What is the remainder? If remainder is 1, then we are here. If remainder is 2, we're here. Remainder is 3 here. Remainder 0 is here. So that's why, oh, this is 5. So 20 and then 20, 5, right? The remainder is 0. So the 20/20 derivative of sine x is gonna be just sine x. So far, so good, everybody. How about if I ask you, oh, what is 507? Okay, you divide it by 4. This is 1, 4, 1, 0. So 2, we give 8, 27, 6, 24. The remainder is 3. So the 507 derivative, which is remainder 3, oh, right here. So that is minus cosine x. Okay, So now can you get the trick? Okay, we just whatever derivative, just divide it by 4 and look at the remainder. So far so good, everybody? Let's continue. So example 4, we want to find the tangent line equation of the function f of x equals 4 sine x cosine x. Okay, remember how to find tangent line? We want to find the derivative. Well, but this guy is a product, so we use product rule. Is the derivative of the first guy times second guy plus the first guy times the derivative of the second guy. Okay. Derivative of sine is cosine, so 4 cosine x, and there is another cosine x, we just copy it down. And then sine x, derivative of cosine is minus sine x. So everybody don't forget your parentheses. The parentheses very important. If you forget the parentheses, then it looks like 4 sine minus sine is 3 sine, but actually here we are multiplying them. So we get 4 cosine squared minus 4 sine squared. Well, that is our derivative. And then we're looking for the derivative at x equals pi over 3. So pi over 3, what is that? Well, we plug in the m tangent equals f prime evaluates at pi over 3. So that is 4 cosine pi over 3 squared minus 4 sine pi over 3 squared. I know what you're doing. Are you grabbing your calculator? Let's try to find the numbers without a calculator. This is the common angle. So I really want to review with you. Okay, everybody try not to use your calculator. Okay? So I want to review of you what are the common angles. So our common angles, we have, so x, it could be 0, pi over 6, pi over 4, pi over 3, and pi over 2. And then what's the sine x? Sine 0, 0. Sine of pi over 6 is 1/2. Sine of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. Sine of pi over 2, 1. So there is a trick to memorize this. You think about this as like square root of n over 2. So that's why the first guy is like n equals to 0. So that's why 0 over 2 is 0. And then pi over 6 is like n equals 1. So you get 1/2. And then n equals 2, 3, 4. Then you get these numbers. Okay, so only one trick can help you to memorize all these numbers. And then how about cosine? Well, cosine is the same numbers, but reverse order. Just reverse it. So 1, root 3 over 2, root 2 over 2, 1/2, and 0. Right? Not that hard. It's the same numbers, and then you just reverse the order. And then what is tangent? Well, tangent, remember, is sine over cosine. So use the first number divided by the lower number. So 0 over 1 is 0. 1/2 divided by square root of 3 over 2. That's 1 over root 3. And then root 2 over 2 over root 2 over 2 is the same thing. So divide. So that's 1. This is root 3. 1 over 0, undefined. Okay. And how about cotangent? Well, cotangent, remember, that is 1 over tangent. Okay? It's actually the same thing, but reverse order. So this is undefined. This is root 3. This is 1. This is 1 over root 3. This is 0. Okay? It's still the same thing, but reverse the order. Okay, how about secant? Well, secant, you know, is 1 over cosine. Where's the cosine? Here. So 1 over that. 1 over 1 is 1. Flip it. So it's 2 over root 3. Flip it. 2 over root 2 is just root 2. Flip it to 1 over 0, undefined. Isn't it easy? And then cosecant x. cosecant x is 1 over sine x. So 1 over 0 undefined. And actually it is the same thing as this, but reverse order. So you have 2 root 2, 2 over root 3, and 1. See, now we have completed the table of the common angle values. Alright, and there's other way you can think of is, the sine graph looks like this, right? This is the sine graph, and this is the cosine graph, and you're looking at pi over 3, yeah? So this is like, this is pi over 2, pi over 3 is right here. So then this guy is a little bit smaller than 1, so this is root 3 over 2, okay? And then we know this is pi over 2. So pi over 3 is a little bit smaller than that. And you can see this. Oh, this is 1/2. Okay. So that's why here. Oh, let me use our orange color back. Okay. So we have 4. Cosine is 1/2 square. Minus 4, this is root 3 over 2 squared. Oh, but 1/2 squared is 1/4. Root 3 over 2 squared is 3 over 4. So you get 1 minus 3 is -2. That is M tangent. Okay, you need so to draw the tangent line equation, to write the tangent line equation, you need the slope, you also need the points. But for the points, we know the x value. The x value is pi over 3. But we also need to know the y coordinates of the points. So we plug pi over 3 into our function f. So we get 4 sine pi over 3 and cosine pi over 3. So sine pi over 3 is root 3 over 2. Cosine pi over 3 is 1/2. Oh, they cancel. We get root 3. So sometimes students get confused. I don't know, this guy is my slope or my y coordinate. This guy is my slope or y coordinate. They mess up. So derivative is the slope. The function is the y coordinates of the point. Okay? So y minus the y coordinate of the point, which is square root of 3, equals the slope, -2, x minus the x value, pi over 3. So, and we can distribute, so y minus root 3 is minus 2x plus 2 pi over 3. Finally, y is -2x plus 2 pi over 3. You add square root of 3 on both sides. So this is the tangent line. Okay, what if the problem asks you to find the normal line? Well, to find a normal line, let me see, do I have enough space here? Okay. So if they ask you to find a normal line, first you want to find the m normal, the slope of the normal line, right? So let me do it here. Okay, for the normal line, m normal is going to be negative reciprocal of the m tangent. So it's going to be 1/2. Then the normal line is y minus the y coordinates. Is still the same thing. 1/2 x minus the x coordinates. So you get distribute 1/2 x minus pi over 6. You add square root of 3 on both sides. So be careful to find the normal line. You can just look at the slope-intercept form of the tangent line and then just replace the slope by the negative reciprocal. That's wrong because the y-intercepts are different. You need to go back to the point slope form and then change your slope here. Okay, so change your slope here and then solve for y to get the slope-intercept form. So far, so good, everybody. And that's it for session 3.4. Have a nice day. Bye.